Hello, so the name of the game today is water. Water's pretty interesting. It can be steam, it can be liquid, and it can be ice. You guys asked some great questions. We're going to go over those questions. Here they are right here. So let's get started. And they revolved around the bug on the water and the geyser at Yellowstone National Park. So we look at water. You may have seen water. It's depicted as H2O. What that means is you have a hydrogen right here and an oxygen right here. Actually, you have two hydrogens. So you have two hydrogens. Let's make these this color. And you have an oxygen, which is this color. So you have two H's and an O. And these guys are connected like this with those bonds. We had talked about bonds. And because electrons are always negative, if we look at these hydrogen bonds right here, we see that just because of the way the charges are, these are more positive than these guys up here. So this is a partial negative and a partial positive. And so what happens is if there is another oxygen that's around here, and a couple hydrogens, and we're stuck like this, and this has the positives over here and the negative right here, these things are going to line up just like a magnet. And so this guy would tend to move down here, and the negative is going to be attracted to the positive, and the positive is going to be attracted to the negative. And so you can end up with these guys lining up like that. So let's look at that a little bit closer. So these guys are going to kind of line up like this. And this thing, when you go across and you keep lining these guys up, you can imagine what that looks like. That makes it really strong. And so how is the bug on water? It's because of how the water molecules are lined up. How is the bug on the water? It's because of how the water molecules are lined up. And surface tension. They line up and it causes surface tension. Let's just call it surface tension. Is one of the reasons. Surface tension. How is the bug on water? Surface tension of the water. So now you can imagine that you have all these atoms down here that are water molecules. And then you have oxygen that's up here, and oxygen is pressing down just from the atmosphere. And so then it makes this surface area stronger than the stuff that's inside of it. And so the surface tension makes it stronger. And so the bug floats because of surface tension, and the bug also has air trapped in its legs. So it's both of those things. So surface tension and air. Now these things are called properties. These are properties of the water. The surface tension, or not the air part, but the surface tension is a property of water. And now we need to talk about the other ones too. Some other properties of water are high specific heat. That means, have you ever noticed when you put a pot on the stove, how much energy that thing takes? It's amazing. If this is a candle, which is representing heat, how much heat you're throwing into that pot of water. If you threw that much heat on a piece of chicken, you'd burn it to a crisp. That's the first thing. So that's another property. Another property is the high heat of vaporization. What that means is, how many times have you watched that pot of water and you start to get a couple little bitty little bitty bubbles, but it doesn't boil. That's because it has a high heat of vaporization. What that means is that, let's say that it takes 1 unit of heat, 1 unit of heat to increase the temperature 1 degree. Right? 1 unit of heat to 1 degree. So if you go from 0 to 212, you're going to put 212 units of heat in there. When you go from 212 to 213, which is where water boils, you have to add an additional a bunch of heat. And do you know what that amount is? It is 144. It's humongous. So 1 unit of heat to increase the temperature 1 degree. But then as soon as you get to just where it's about to boil, it takes 144 more units to get it to start boiling. That's crazy. So that's another one. A third one is the low density of ice. A lead ball is more dense than a balloon, so it sinks. So lower density means it's lighter, and that's why ice floats. And then the high polarity, that adds to the surface tension, what we drew before. It's polar, like a magnet, right? So pretty cool. So those are properties. You have surface tension due to the high polarity. That's why bugs float on water, and also the air on their legs. The lower density of the ice lets it float. The high heat of vaporization, it takes an incredible amount of heat to get that thing to boil, and that's why you shouldn't stare at a pot to make it boil. High specific heat, it can absorb a lot of energy, meaning you can throw a lot of heat at it and it's not going to affect it. You can put a blowtorch to a pot of water and it's going to take it a while to get it to boil because the high specific heat of water. So another thing we looked at is, why does the steam seem like it's under pressure? And so when we look at a geyser, here we have the surface, and then we have this long tube. And let's pretend like you put your lips on this long, these are lips. See that? Then that look just like lips. We'll color them red. And let's pretend like this is a long straw that's like, a quarter of a mile long, and you're going to blow something up. It would take a lot of pressure to do that, right? And so it is under pressure. And so just having all the atmosphere right here, atmosphere, I just butchered that word, but you know what I'm talking about. All this atmosphere is pushing down, and as you go up in altitude, there's less atmosphere pushing down on you. But we have this atmosphere pushing down, and so this is pushing down here too. And then, if that straw was like way, way, way down, there'd be more things pushing down on it than if the straw was like really short and was only 6 inches. And then you had to, I know you all want to see me make my lips again. Terrible drawing. How would it be? So then you could maybe, here, I'll pause and I'll try and draw a face. How's that? There's a face. See it sideways? He's blowing it up. But it would be a lot easier because there'd only be a little bit of atmospheric pressure. So it is under pressure. Why does the steam seem like it is under pressure? Because it is. What's holding it back before it escapes? The heat has to build up. And so let's convert these into flames, because this is going way, way down deep inside. And so that's got to heat up it's got to heat up a bunch of water. And then finally it goes boosh, and it blows it all up, and then you've lost that water, and then the water seeps back in, then you have to heat the water back up. It reaches that high heat of vaporization, and then it blows it out again. What is holding it back before it escapes? Atmosphere. What is holding it back before it escapes? Atmosphere. Why does the steam seem like it's under pressure? It is. Atmosphere. What is holding it back? Atmosphere. What makes it so hot? The center of the earth is hot. Oh, there's the wrong color again. The center of the earth is hot. And why is there so much water? There's lots of underground water. And so there's just lots of it. If we look at why does the ball of water bounce in the surface? Surface tension. God, I can't spell today. Surface tension. I'm not going to spell it again. Ten is sun. Tension. We just need to move this little I around and then we're okay. Surface tension. And so when you have H2O, you can break this apart. We already talked about breaking bonds, right? We talked about breaking bonds when we exploded stuff. So we can take this thing apart and we could arrange it in different ways. But one of the ways we can do it is 0H and H, right? We still have the two H's here. One's right here and the second one's right here. And here is our single oxygen. And so when we have this, the OH here is negative, and this guy stays positive, just like we saw in the first part of this little video. And what this makes is an acid. The more of this you have, the more of an acid you have, like vinegar. And the more of this guy you have is more of a base, like ammonia. So you're just breaking apart essentially kind of a water, and you can turn those into an acid and a base. So there we have it. So maybe I'll go backwards. So we have the acid and the base. You break the water apart into OH and H. Why does the ball of water bounce on the surface? Because of surface tension. Surface tension right here. Because the outside of that ball is stronger than the inside, and so then when you have two different surfaces come in contact, they can bounce. Why does the steam seem like it's under pressure? It is. What is holding it back? Atmosphere. Why is it so hot? The inside of the earth is really hot. And why is there so much water? There's lots of groundwater that can form pools, and then that hot underground heats that water up, just like Baranof Warm Springs right in our neighborhood. Does the bug float because of surface tension or the air trapped in its leg hairs, or both? It's both. Surface tension and that it has air in the teeny tiny hairs on its legs. How is the bug on the water? Surface tension. That's the basic thing. Things can float on water because of surface tension. And then we just have water. It occurs in three different phases: steam, ice, liquid. That's all.